Hello, I'm Daniel Braun from the University of Cologne, and this presentation is about the visual validation of the average value in scatterplots and its performance compared to visual estimation. The paper is the result of a collaboration of computer scientists from the University of Cologne, Tufts University, and the University of Wisconsin-Madison. Validation is an essential part of building regression models. Often, statistical analysis alone is not sufficient to validate model results, and visual testing is needed. Examples are the dinosaur datasets or Simpson's paradox. While in the past the visual model estimation has been widely researched, visual model validation remains under-investigated. Since the visual estimation of average values in scatterplots has been studied in recent papers, we used this model as a starting point for our validation research. As a consequence, we identified two research questions. First, are individuals able to perform visual validation consistently and without bias? And second, how does the performance in visual validation relate to the accuracy of visual estimation? To answer these questions, we conducted a user study in which two tasks had to be performed on scatterplots with 100 normally distributed data points. In the estimation task, participants had to estimate the average height of the dots by their own. In the validation task, they were shown a line and had to either accept or reject this line as the average value. For both tasks, we quantified the deviation of a line as the deviation from the true mean as a proportion of the standard deviation. A total of 190 participants took part in the between-subject online study, from which 100 were volunteers and 90 were recruited via the crowdsourcing platform Prolific. Both populations included a wide range of statistical expertise. The analysis of the study revealed three main results. At first, the threshold of accuracy of a model at which a viewer accepts it as valid is lower than the accuracy of visual estimation. This can be seen by comparing the cumulative distribution of the estimation errors with the acceptance rates of the validated lines. Here, the x-axis indicates the deviation of the estimated and validated values from the true mean, and the green line shows the border of the true mean's 95% confidence interval. This result implies that people accept models that are less accurate than models they can visually estimate. Comparing the two populations, the results for validation were almost identical, while the volunteered population was more accurate in estimation. The next result is that it makes no difference whether the value to be validated is above or below the true mean, which means that visual validation is unbiased. And as a third result, we found that participants' natural critical point between accepting and rejecting a given value, which means the deviation of lines with a 50% acceptance rate, is close to the border of the 95% confidence interval of the true mean. This finding is supported when looking at the distribution of the individual critical points. Especially for the volunteered population, these are normally distributed around the 95% CI border. Additional results are: there was no significant difference in the response time between the two tasks, as well as no significant difference in the reported difficulties. After this first study on visual validation, there are many possibilities for future work. For example, we haven't considered special data characteristics, such as outlier or distributions. Furthermore, it would be interesting to investigate more complex models or other visualization types. In summary, we started our investigation of visual model validation with a study on the average value in scatterplots. Our results show that the accuracy of the acceptance threshold for visual validation is lower than the accuracy of visual estimation. Furthermore, visual validation is unbiased and its critical point is close to the 95% confidence interval of the true mean. I thank you very much for your attention.